So certainly using discriminants and those row reduction techniques is a way to solve these. In fact, some of the videos, the AI will show you how to do it that way. What I was hoping you would do was, if you watched my videos about using calculators, if you got a graphing calculator, it works slick. I'm assuming people don't have that, so I'm going to show you an online calculator. And this was in my video that I made for this. So. Let me see if I can't pop that open. It's going to make me, just a minute here. It's going to make me come back here, and this computer's a little quirky. Oh, let's see. So it's math is fun here. Let me come back here and I'm going to share my screen, show you. I might get links to this in Canvas, but I'll show you how I do it when I do it when I'm just looking. So if I do math is fun, it's fun, and I think it's kind of a matrix calculator. I think this is it. Yeah. And oh, good. And Zoom didn't lose what I wrote. So I wrote that system as a matrix equation, and just like with a linear equation, if watch them or yeah, any kind of really it's any kind of equation, but linear was what I was thinking of. You do the multiplicative inverse here. Let me get a pointer so you can see what I'm pointing at. Okay, right, so there's the coefficient matrix, and if this is like if you take the inverse multiplicative inverse of that times the constants, you'll get the answer. So, and by hand finding the multiplicative inverse of a matrix is a pain in the butt. For a 2 by 2 system wasn't bad, and you did that with your using the discriminants, but you can also just use this calculator for it. So I've got a 2 rows, 2 column matrix, and I'm going to type in my numbers here. So what is it? -5, -1. -1. And honestly, with a 2 by 2 system, this probably wouldn't have been too bad to solve by hand, just like using elimination or something like that. But since we're trying to get you a little bit beyond that, so I got that typed in right. And then the constant matrix is a 2 by 1 matrix, 2 rows, 1 column with that -200 and -400, -200, -400. Then what this calculator will do, once you get that typed in, now comes the easy part. You're going to do the inverse of A. So what this button right here, see how it's the inverse of A? That'll find the multiplicative inverse of A. When you multiply this matrix times that inverse matrix, you're going to get the identity matrix, the multiplicative identity. It's in matrix form. It's 1, 0, 0, 1, but we don't need to know that. So I'm going to inverse. There's the inverse of that matrix. And then what you want to do is you want to save that matrix to matrix A, and then we're going to multiply A times B. So this is A inverse now times B. So A inverse, where is AB? And there's the answer. And of course, the calculator is doing the, you know, base 10 to hexadecimal probably, and then back to base 10. So 25 and 75 are what the values are. Okay. So that's a much easier. I'm thinking that's much easier than doing it all the matrix division and all that. All the not matrix division, all the determinants and all that. So you're welcome to do it. If you've got a graphing calculator, do it. I mean, you can find plenty of videos on how to find the inverse on that. And if you can't find it, let me know and I can make one. I probably already have one somewhere, but. Okay, so hopefully you embrace this. Um, you'll have on the next quiz in the week 14 quiz. I'm giving you like a 4 by 4 or 5 by 5 matrix. Be a pain in the butt to do it by hand. You're going to want to use tech for it. Okay. All right. That's long enough video. Let me know if you need anything.